Okay, so today we're going to talk about inscribed polygons, and we've heard this word inscribed before when we talked about inscribed angles. So before we get started with some examples, let's talk about some vocabulary and two theorems. So the first vocabulary definition I want you to fill in here is that if all of the vertices of a polygon lie on a circle, then the polygon is blank in the circle. The word that this is inscribed. And you've seen that word before. We've talked about inscribed shapes. We've talked about inscribed angles. That word inscribed just means that the object that we're talking about is inside of something else. So let's keep reading. If all of the vertices of a polygon lie on a circle, the polygon is inscribed in the circle, and the circle is circumscribed about the polygon. So if you look at this diagram over here, the word circumscribed circle is referring to this green circle. I know my circle isn't as good as the drawing, but you see what I'm pointing out here. The circle is around the shape, and then the shape that's actually inside of the circle is the inscribed shape. So this would be the inscribed triangle, and over here, this would be the inscribed quadrilateral. Remember, quadrilateral is a shape with 4 sides. So what we would call these in this next sentence here is the polygon is an inscribed polygon, and the circle is called a circumscribed circle. Okay, now the theorems down below here, I'll do this theorem on the left. It says if a right triangle is inscribed in a circle, then the hypotenuse is a blank of the circle. So if you look at this diagram, we can see, I'm going to outline angle B is an inscribed angle, and that inscribed angle is intercepting this arc, which happens to be a semicircle. And semicircles measure 180 degrees, which means angle B, which is the inscribed angle, is half of that. So angle B is going to be 90 degrees. So that's why we're saying this is a right triangle. A right triangle is a triangle that has one angle measuring 90 degrees. So if we have a right triangle that's inscribed in a circle, then the hypotenuse is always going to be a diameter of the circle. And the second theorem I want to talk about in this box, this theorem states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And you've seen the word supplementary before. Supplementary means that they sum to 180 degrees. So, for example, angle D and angle F, if I were to take the measurement of angle D and add that to the measurement of angle F, I would get 180 degrees. And similarly, if I were to take angle E and add that to the measurement of angle G, I would also get 180 degrees. So this vocabulary and these two theorems are what we're going to use and apply to help solve some of these example problems. So moving down below, I will do a few of these examples with you, and the rest you can try on your own or with your groups. So for example 1, I'll do example A. The first angle that stands out to me is this inscribed angle, and the reason this angle stands out to me is because this angle, or this inscribed angle I should call it, intercepts a semicircle. And again, a semicircle is 180 degrees. So if this angle, which is called angle X, it intercepts the semicircle, I know right away that the measurement of that angle is going to be 90 degrees. So I know X is 90 degrees. Now, the problem wants me to find the values of X and Y. I just found X. And I know that this angle over here is 35 degrees, and I know I have a triangle. So now this makes it really easy for me to find the measurement of y. So if I know that there are 180 degrees in a triangle, and I just found that one angle is 90, I know that the other angle is 35, taking those both away from 180 gets me 55. So I know that y is going to be 55 degrees. So that's how you would do example 1a. Examples 1b and c are very similar. Again, you have inscribed triangles, and I'll save those for you to do on your own. Let's skip down to example 2. Example 2a and b, now these are starting to deal with quadrilaterals. So I know that in this quadrilateral, the opposite angles, and I'll highlight them in different colors, I know that these opposite angles are going to sum to 180 degrees. So for instance, if I want to solve for x, I know that when I take x and I add it to the opposite angle, which is 74, I'm going to come up with 180 degrees. And if I want to solve for y, I know that when I take y and I add it to the opposite angle, which is 94, I'm also going to get 180 degrees. So to solve for x, let's go back up here. Let's subtract 74 from both sides. And using my calculator, 180 take away 74 gets me 106, meaning x is 106. And then down here, solving for y, I'm going to take away 94 from both sides, and 180 take away 94 gets me 86, meaning y is 86. And similarly, you would do the same for example B, and I will save that for you to try on your own or with your groups. Moving to the back, they want us to find the value of x, and then they want us to find the measures of all the interior angles of quadrilateral ABCD. So here, right away my eyes are drawn towards the two angles that have measurements, and they are opposite of one another. So I know that the measurement of angle B added to the measurement of angle D should give me 180 degrees. And this is the relationship and equation I'm going to use to help me find the value of x. So the measurement of angle B is 95 degrees, plus the measurement of angle D, which is x minus 25 degrees, is equal to 180. This is my equation that's going to help me solve x. So I'm going to write solve for x. So from here I'm going to combine my like terms. So 95 take away 25, it's going to give me 70, so I have x plus 70 on this side, and that's still equal to 180. Subtracting 70 on both sides gets me an x value of 110. So from here I can find the measurements of all of my angles. So the measurement of angle A, since the measurement of angle A is just x, and I know x is 110, I know the measurement of angle A is 110 degrees. The measurement of angle B, well, that's given to us. The measurement of angle B was 95 degrees. The measurement of angle C, well, if I know the measurement of angle A, was 110 degrees, then I know that the measurement of angle C has to be the supplement of that. So the measurement of angle C will be 70 degrees. And then lastly, the measurement of angle D is going to be the 110 take away 25. So 110 take away 25 gives me an angle measurement for angle D of 85 degrees. Now it's super important that you have all of the measurements of which specific angles you're talking about. So I know, for example, the measurement of angle A is 110. The measurement of angle B is 95. I'm not just randomly writing angle measurements, I'm specifying which angle equals that measurement. So at this point, I want you to look over all the notes you just took, refer back to the vocabulary and the theorems on the front page, and I want you to complete the rest of this handout. So I want you to go back to the example 1 and 2 and finish those, and then when you're ready, I want you to try number 4 on the back side of this page.